A Certec EDA webinar. This webinar will last about 20 to 30 minutes and will be discussing aspects related to design for manufacturability of the bare printed circuit boards. My name's Kevin. It's my pleasure to present this webinar to you. We hope that this session will provide you with valuable information and that you'll be able to apply some of the points discussed to better optimize your design by making it more manufacturable and at the same time doing some cost savings. Our slogan at Certec EDA is we don't just sell PCBs, we sell sleep. Our mission is to give you better peace of mind in knowing that you have your bare printed circuit board requirements under control. Feel free to visit our website at www.certec-eda.com for more technical resource information as well as previously hosted webinars. I'm sure that you'll find our website useful and full of valuable information. Certec EDA is the exclusive representative of the NCAB Group, with its head office based in Sweden. The NCAB Group is well known for providing high-quality PC boards at all levels of technology. Then just on the side note, quality PCBs are expensive. Better quality PCBs are even more expensive, but the best quality PCBs are priceless. At Certec EDA, we'd like to play an active part in ensuring that your PC boards are the best quality at the best possible price every time. Now, getting back to design for manufacturing, some of the issues I'll discuss with you now will be fairly obvious, others won't be as obvious. Okay, design for manufacturability is the design process of a circuit board that meets the following criteria. First of all, the circuit board must function as it's designed to do it. The capabilities of the design itself must be met. Then the circuit board must also be easily manufacturable, even at volume levels, so the capability of this printed circuit board fabrication process must be met. Okay, areas relevant to design for manufacture. Common areas in the documentation. Good design. The required tolerances. Reduction or ideally elimination of engineering questions or queries. Now, the main aspects of design for manufacture include the following. First of all, data pack specification, material selection, multi-layer stack-up requirements, tolerances related to manufacturing, data generation issues, solder mask openings and bridges, annular ring and clearance, copper balance and design, copper thickness and track width, drill diameter and aspect ratios, and laminate material yield. We'll discuss each of these items one by one. We'll touch on each of them. Let's start with manufacturing data pack specification. The data pack itself contains information required for the PCB manufacturer to properly and accurately interpret the design. So the most common errors that occur relate to information that is either missing or ambiguous or incomprehensible or conflicting. Now, each of those issues can lead to engineering queries being raised, which does cause delays, and worst case scenario, lead time starts shifting out, delivery time starts shifting out. Okay, typical examples of missing information is missing outline information or missing data, missing drawings, plated or non-throttle plated identification, the surface finish of the PCB, the copper thickness requirement of each of the layers on the PCB, the laminate material thickness and details, the color of the solder mask and the legend, the final finished PCB thickness, and missing Gerber or drill files. And the list goes on. What you see there, listed there, is the most obvious, or are the most obvious issues that we experience. Okay, examples of problematic information is where the given board thickness does not match the specified build. The legend is included in the documentation but is not required to be printed. Dimensions listed in the drawing do not match the Gerber outline. The number of holes in the drill drawing do not match the number of holes detailed in the supplied file. Continuing, the hole sizes in the drill drawing do not match the hole sizes in the drill file. The copper thickness in the specification differs from the stated build, and the specified impedance requirements cannot be achieved based on the stated layer build. Okay, recommendations to try and avoid these type of issues from occurring. First of all, send the information that is relevant to the PCB manufacturing process only. So as an example, if your legend layers don't need to be on the PC board, then omit them from the data pack that is sent through for PCB manufacturing or for quoting. Avoid too much information. Information like assembly files, pick and place files, etc., aren't required for manufacturing, so those can be omitted. Then specify internationally recognized standards. Something like IPC, if your product does require a standard that is not that easily recognized, then it would be a good idea to extract the detail from that standard and to include that into your data pack. Okay, material selection. Okay, FR4 is no longer just FR4. In fact, there are in excess of 200 different types of FR4, and they each have a vast range of specifications and obviously price variations as well. Even exotic materials, that would be materials like Bergquist thermal, aluminium substrates, and high-frequency materials also come in a vast range of specifications. So the PCB manufacturer is frequently allowed to select the base material. As an example, the data pack would specify the material to the requirement to be FR4, and that can leave the actual material up to the choice of that material is left to the manufacturer's choice. They can decide to choose the cheapest material. Okay, material availability could also pose a problem. So the material that you've selected may not be easily available or readily available at the manufacturer. Okay, Certec EDA is more than willing to assist you in the process of material selection. So give us a shout, we can help you there in selecting the right type of material for your design. Okay, multi-layer stack-up requirements. Creating a multi-layer stack-up can be a daunting task with many challenges. For example, material specifications, material availability, impedance requirements, blind and buried wires, and embedded component requirements. Now, once again, Certec EDA is more than willing to assist in the process of a multi-layer stack-up generation. We can help you to choose the right stack-up for your design. But then please speak to us early in the design phase. We can set that in stone early, and that'll help your design process. Okay, manufacturing tolerances. Perfection is always strived for, not always achieved. A printed circuit board is a manufactured item where each of the manufacturing stages during the PC board production process has optimum parameters and associated tolerances that have a direct influence on the finished product. Now, arcade data shows us an ideal PC board. Everything is lined up nicely, but in the real world, nothing is that precise. So the final product measurements will vary from the ideal in numerous ways, the acceptability of which is based on the tolerance specification limits. Okay, so consider the reality of manufacturing tolerances during the design and layout of your bare PCBs. Data generation issues. Copper slivers. On the left-hand image, you can see small copper slivers in between the tracks. This is normally caused by a ground pour that's been done where the aperture choice is, the apertures are too narrow. On the right-hand side, you can see what it should look like. Unflashed pads. On the left-hand side, you can see that the entire layer has been made up of lines. This ends up becoming very memory intensive. So once you've saved all the files, the overall file, the overall data pack becomes extremely large and almost difficult to email, if possibly even impossible to email. Okay, same net spacing. You can see in both of those images there are spacing violations, even though it's from the same net. That does pose problems as far as PCB manufacturing goes. So the software is deviated from the set clearance when routing is done within the same net. Okay, solder mask openings and bridges. As you can see there, the solder mask is nicely centered onto the pads. No problem there, that's an ideal world. If we take that solder mask and we displace it in a direction, you can see around the pink circle that the solder mask is displaced to a point where it may actually be exposing copper on the tracks. And that can itself cause, it's a recipe for a short circuit. Okay, maintain the specifications or the capabilities of the manufacturer. So be aware of them, especially when it comes to solder mask bridges. And if you have a component that has a solder mask, that has a pitch that cannot accommodate a solder mask bridge, it's better to remove the bridge completely. Okay, we can see an example of a wire that is very close to a solder pad. What can happen if the solder mask is slightly offset, the wire hole may be exposed, and during the soldering process, the molten solder will be sucked into the wire hole. It's going to starve the actual joint of solder, and you're going to end up with a bad joint ultimately. So try to keep a decent solder mask bridge between the wire and the pad so that you can avoid any problematic soldering as a result of the wire hole being exposed. Okay, annular ring and clearance. Again, a close-up of a VGA. You can see the dog bone shapes, and the holes for the wires are nicely centered. If we take those holes and we move them to one extreme, we'll see that there is a breakout. It's about a 90-degree breakout, but that is still acceptable as far as IPC Class 2 standards go. If we take that same hole and we move it over to the other side, then we're starting to compromise the junction between the track and the pad, the wire pad, and that is obviously going to be a reject regarding IPC Class 2 standards. So what we recommend doing is to consider the option of using teardrops for your design, so that if there is a slight deviation in the hole, that you're not compromising the junction between the track and the pad itself. Okay, copper balance and design. There's an example of a poor copper balance, a lot of copper on the right-hand side, a lot less on the left-hand side. This can lead to all sorts of issues. Mainly the copper plating process will be a problem, as well as warpage on multi-layer boards. So poor copper balance leads to excessive and uneven copper plating, as in the image on the left-hand side, and good copper balance leads to an even copper plating. Additional copper should sometimes be used to balance the sparse areas. As you can see in the image over there on the left, there's a fair imbalance of copper, and there's a lot of open space. On the image on the right, what has been used is copper thieving to balance out the copper area and drastically improve the plating process, the copper plating process. Okay, copper thickness and track width. So NCAB has perfected the art of being able to plate the inside of the holes to a minimum of 25 microns. And normally the plating thickness itself is between 15 and 35 microns. So if we take an example and we use an 18 micron base copper and we plate on top of that, we get to a final finish of about 30 to 50 microns. Okay, the thicker the final finished requirement, the thicker the base copper needs to be, because plating more than 25 microns of copper results in overplating. As you can see above there, the blue is the photoresist, and the pink over there is the copper. You can see the copper is clearly overplating beyond the photoresist. Okay, thick copper base can, however, lead to difficulties and challenges while etching. A thicker base copper will result in greater track and gap requirements. So you'll need a wider track and gap the thicker the base copper goes. Drill diameter and aspect ratios. Okay, aspect ratio by definition is the ratio between the minimum hole diameter and the overall thickness of the board. So as an example, if the board thickness is 1.6 millimeters, and the minimum hole size is 0.4 millimeters, then you have an aspect ratio of 1 to 4. So higher aspect ratios are more difficult to produce. Okay. Copper plating inside through holes depends on how easily the plating solution flows through the hole. So when the solution flow is restricted or problematic, the copper plating will end up being thinner towards the center of the hole. Be aware of the manufacturer's aspect ratio capabilities when selecting the minimum hole size for your design. All right, drilling of small holes sets high demands on the equipment, and it also reduces the number of production panels that can be drilled in a stack at any given time. Be aware of that as well. All right, material yield. A large part of the cost is related to the raw material, which is a fairly obvious statement. It's therefore important to have a good material yield to avoid scrapping of unused processed material. Essentially, you want to use as much of that material constructively as possible. You want as little wastage as possible. So not only can material yields be improved by means of panelization, but costs can be saved if the redesigns are permitted. And this applies to all types of material, but especially the higher grade materials or the exotic materials, which are the aluminium substrates and the high frequency materials. They cost a lot more than what the FR4 laminate does cost. So talk to us. We can help you to optimize your design and to maximize your material yield. Okay, well, that was my contribution. I hope it was of some use to you. If there are any questions relating to this webinar, please make use of the quick chat facility on our website, or feel free to email us at ineedpcbs@certic-eda.com, and we'll get back to you. At Certic EDA, we have a dedicated team who are more than willing to assist in any way we can. We can help you to make sure that you have the most cost-effective designs and high-quality products. So please don't hesitate to contact us. A recording of this webinar will be made available on our website within the next day or two. Our next webinar will be taking place on the 8th of October, which is the second Thursday of next month. The subject will be HDI, or High Density Interconnect. We're looking forward to you joining us again. Thank you for your time. I hope you enjoyed it. Feel free to visit our website at www.certic-eda.com, where you'll find our contact details, as well as a lot of useful information, including previously hosted seminars. So thank you once again. Have a great day. We look forward to presenting this next webinar to you again. Remember, at Certic EDA, we don't just sell PCBs, we sell sleep. Cheers and God bless.